The presentation logic holder we are going to use in the number trivia app is Bloc. We've already set up its events and states in the previous part, and now comes the time to start putting it all together doing test-driven development with Dart's streams. Testing with streams is actually quite a bit different than all of the tests we've written up until now, so there is really a lot to learn. Hello, welcome to ResoCoder, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. We have events, which is get trivia for concrete number and also for random number. We have states, empty, loading, loaded, and error. And also we have the block, which we are about to implement. Sure, the block can already work with these events and states, but in addition to that, we also have to think about which dependencies will the block have. And since block or any other presentation logic holder, so for example, mobXStore, reducer, change notifier, whatever, since presentation logic holders are at the boundary between the domain and presentation layers, it will depend on use cases we have in our app. So those are get concrete number trivia and also get random number trivia. And of course, it's also going to depend on the input converter we've made in the previous part. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video and overall go through this lesson at your own pace. We've usually created the test first and only then created the constructor, but in fact that's not really necessary because constructors do not hold any real logic. So we can go the other way and create the fields and the constructor first and only then use it from within the test. It's not breaking test-driven development because again there is no logic, and actually it's easier to write the test once you have the constructor in place. So we're going to depend on get concrete number trivia use case. So get concrete number trivia will be its name. Then also we are going to have get random number trivia. And let's rename even the field to get random number trivia. Let's import these use cases over to here. And the last dependency will be, of course, the already mentioned input converter. So let's import even that. And we're going to create constructor for final fields. And this constructor should in fact be optional, but also required, so that these will be named parameters. So let's add a curly brace to wrap the constructor contents and then annotate every single parameter with required. So let's import meta.dart. And after every single parameter is required, we're going to do something which we haven't yet done in this tutorial course because it's quite time consuming. But you can do it always when you have some sort of a constructor, because Dart does not support non-nullable types yet. It's on the horizon, but as of now, Dart does not support non-nullables. You can ensure that nulls are not passed into the constructor by asserting. So after a constructor, after the colon, we can assert that get concrete number trivia doesn't equal null. But this get concrete number trivia is quite a long name to have in a constructor, especially since it's a named parameter. Whenever we are constructing a new instance of number trivia block, we will have to specify this whole name inside the constructor invocation. So let's actually change this to just concrete. So we're going to need to specify the type and then concrete. But what this will do is that we are no longer using the shorthand of assigning the field directly in the constructor. So we will have to assign this field like this. we have to set the field. So get concrete number trivia is its name to be equal to concrete, which is a parameter of the constructor. And now we are also going to use this concrete from within the assert. Similarly, we want to shorten the parameter name of the get random number trivia. So we are going to just copy get random number trivia type and call it random. We also want to assign get random number trivia to be the random parameter. And also for all of the other parameters, we want to assert that they are not null. So random should not be null, and also input converter should not be null. And this way we have a somewhat more safe constructor, a safer way to construct our number trivia block instances. And this constructor structure applies obviously to all of the other classes which we have created up until now. It's not really needed, but if you really want to make sure that null values are not passed in, this is the way to go until Dart supports non-nullable types. All right, now we have the constructor in place together with the fields for the dependencies. So we can go over and create the test. As usual, it will be present inside a mirrored location. So inside the block folder, we're going to create a new, not folder, but new file, which will be called number trivia block test.dart. And inside it, as usual, we are going to import all of the usual packages. So those are going to be copied from other tests, for example, from the repository test. We're going to copy Mockito, darts we can copy as well. So let's just copy that and paste it into this new test file. And of course, we're now going to mock all of the dependencies, which are get concrete number trivia. So we're going to just copy this type because it's quite long to type out manually. So class mock get concrete number trivia extends mock and implements get concrete number trivia, which we of course need to import. Similarly, we're going to have mock get random number trivia use case. So let's just rename concrete to random. And also it will be implementing get random number trivia, which we again need to import over here. And lastly, we're going to have a mocked input converter. So again, extending mock, implementing input converter. Now inside the main method, as usual, we're going to set everything up. So we want to have the instance stored of the actual block which we are testing. So number trivia block. Block is going to be its name. So let's import our number trivia block, or we can actually import the barrel file. So we're going to import block.dart, which in turn also imports the events and states. Then we also want to have instances of those mocks, which we have created above the classes for them. So mock get concrete number trivia, mock random number trivia, and also mock input converter. And now inside the setup method, we're going to instantiate all of the mocked dependencies. So mock get concrete is equal to mock get concrete, and so on and so forth. Sadly, Dart's tests simply do not support some shorthand annotations. Maybe someone will create something like that in the future, I don't know. But it's just what we have to do with Dart. We have to be repetitive in our tests. So mock input converter will be equal to mock input converter. All right. And that's about it for these mocks. And whoops, now we need to pass these mocks over to the blocks constructor. So we are also going to instantiate our block. and use the name parameters. As you can see, we do not have get concrete number trivia name, but instead we just call it concrete to make it shorter, which is definitely a good thing. We're going to pass in the mock random, again pass in the random mock, so mock random. I cannot even type these long names anymore. And input converter, we're going to pass in the mock input converter. And after this line of horrendously long code is formatted, we have the test successfully set up. The first test we're going to write will be for a functionality which is actually already implemented. Because what's the first thing that a block should do? Well, the first thing that block does is that it emits its initial state. And as you can see inside the number trivia block, we already have the initial state implemented, and the initial state will be emitted to be empty. That's not something we've implemented. It's been implemented by the code generation, by the VS Code extension in the previous part. But I mean, it's already implemented, so we're not going to delete it just so that we can have proper test-driven development experience, right? So we're going to write the test for code which is already implemented in this instance. The test for it will be very simple. We're just going to write the regular test. It will not even be the arrange, act, assert test because there is really nothing to arrange here. So we're going to test that initial state should be empty. And inside here, we're just going to basically assert that we expect the block's initial state to be empty. So equals empty. And once we run this code, it's going to, of course, pass. So if we open up the block test, we can see that initial state should be empty, passes, which is nice. Now, this is sort of a special case of a block test because we are not testing with streams. All of the other tests will be working with streams because block works in a way that you dispatch events to the block. They arrive inside this map event to state method. As you can see, it has a parameter of the event type. Here we are going to decide based on the event type. For example, if it's get random number trivia, we're going to get random trivia. If it's get concrete number trivia, we're going to get, of course, concrete trivia. So based on the event type, we're going to decide which logic we should run. And then we're going to emit states using this stream here. And usually the events will arrive inside this map event to state being dispatched from the UI. So from the widgets, we're going to dispatch events to the block. However, inside tests, we're going to have to sort of mimic the UI because we are going to dispatch the events directly from the tests in order for us to be able to test the functionality of the block, of course. In this part, we're gonna start testing with the get trivia for concrete number event. So we're gonna create a group for that. Get trivia for concrete number. And let's actually also set up all of the variables which are going to be needed throughout this test group. So get trivia for concrete number, if you've forgotten from the previous part, this event takes in a number string, which we'll want to convert to an integer using the input converter, which is a dependency on the block, right? So we're going to need number string. The number string will be its name. And let's just set it to be a string representation of the integer 1. Then, of course, since we are mocking the input converter, we need to mock its output. And the output of an input converter is, of course, an integer because it converts strings, validates them also, and outputs a regular integer. So the real integer of this string representation will be 1. So final t number is equal to 1. Or let's actually call it t number parsed so that it's more clear. And lastly, the block will output or emit states. And one of those states, if we take a look at it, needs to take in a number trivia instance. So we are also going to create an instance of that entity. So inside the test file, let's create final t number trivia, which will be equal to a new instance of number trivia containing the number, which will be 1, and text, let's just set it to test trivia. The most important thing to happen when a get trivia for concrete number event is dispatched from the UI is to make sure that the string gotten from the UI is a valid positive integer. We've already implemented this conversion and validation logic in the previous part inside the input converter, and we've already tested it with the input converter test. So we no longer need to test it again. We can rely that input converter is a fully functional and tested class. So therefore, we can just simply mock it and not care about its implementation details here inside this block test. The first thing that should happen when this get trivia for concrete number event is dispatched, therefore, should be that the block should call the input converter to validate and convert the string to an unsigned integer. So we're going to create the range act assert test, should call the input converter to validate and convert the string to an unsigned integer. We're gonna mark it as any other class. So let's just say when the input converter, or actually mock input converters method called string to unsigned integer is called. Here we can just specify with any argument because we are just mocking it. We don't care at this point which number string is passed in. Then we want to return, because it's a synchronous call, not asynchronous but synchronous. We want to return write because it's also using the either type. So we want to return success, that the number was parsed successfully. So we want to return t number parsed, which is the integer 1. Now we are still not testing with streams because we are just testing whether or not this input converters method has been called. So for now we are going to do things regularly as we've done them before inside all of the previous tests. So we're just going to simply call block.dispatch. We're going to dispatch get trivia for concrete number and pass in the t number string, because UI only works with strings and all of the conversion logic is inside the input converter. And then we can just verify inside the assert part that mock input converter dot string to unsigned integer has been called with the number string, because this is all we are going to check for inside this test. So we should be good to go, right? Now when we run the test, it's of course going to fail. So we're gonna go to number trivia block and add this logic over here. So we're actually going to unusually immediately check for the type of the event. This may seem that we are implementing more logic than is necessary for this test to pass, but that is not so, because checking for a type of an event, so we're going to check for event is get trivia for concrete number. Doing this will perform a smart cast. So within this if block, we can already use the event as if it was the concrete number event and not just some instance of the base class number trivia event. And to fulfill the test, we just want to call the input converter dependency that get or that string to unsigned integer and pass in the event dot number string. So after we save this and rerun the tests, they should pass, right? But they do not. Why is that? Well, we triggered the logic for this map event to state method by dispatching an event from this test. And events arrive inside a sink, and which is basically a stream. And overall, all of this is asynchronous. So it takes some time for the block to start executing the logic present inside map event to state. And it takes long enough that if we do not await something inside this test, this verify call will be executed before the string to unsigned integer had a chance to run from within map event to state inside the block. So even though we are doing what the test prescribes, we need to await for this mocked method to be called from within the test. We can do that using Mockito's until called method, and we're going to await it. So we're going to await until called, and let's just await until mock input converters string to unsigned integer with any argument is called. And now this test will be halted until this call is performed. And once it is, it's going to continue. And this way, we've just made this test to pass. We are now only testing if the input converters method is called, but of course the output of this input converter, something has to be done with it. If the conversion is successful, the code will continue with getting data from the getConcreteNumber trivia use case, and we are going to test that thoroughly in additional tests, which we are going to write in the next part. But if the conversion fails, we need to emit an error state from the block saying that the input is invalid. We need to inform the user, for example, if he inputs ABC, that's definitely not a valid integer. We need to tell the user that, oh, you've done something wrong, you need to input a valid integer, right? If we take a look at the error state about which I was talking, we can see error state contains a message, which is a string. And as we are emitting this error state from the block, so we are gonna do something like yield error and pass in the message. We could always specify the message as a string literal, so invalid input, but doing this is not a good practice because like you're passing around magical strings again. So we're going to skip ahead a bit and create constants for all of the possible errors for every single failure that can occur inside the block. So which kinds of failures can happen inside the block? Well, we have the input converter, which can return the invalid input failure. And then we have the use cases, which both can return server failures or cache failures. So really, let's just skip ahead a bit so that we do not need to come back to creating these constants all the time. And we're going to create all of the constants for the error messages right now. So above the number trivia block class, we're just going to simply create const string server failure message. And when something like this happens, we are going to tell to the user that some server failure happened. So we're just going to simply say server failure. And of course, instead of messages, you could also use some error code. So for example, 100, and this would mean server failure, and this would allow you to localize these error codes from within the UI, from within the widgets, because Bloc should not access localization. But since we are building only a simple app, we are going to probably stick with messages because it's just simple to work with. Then similarly, we want to have cache failure message, which will say cache failure. And finally, we are going to have invalid input failure message, which will say something longer. We're going to say invalid input. The number must be a positive integer or 0. And with these error messages set up, we can now finally test what will happen if the input converter returns a failure, because in that case, we should emit an error state. So let's create a new AAA test. So range act assert. And this test should test that the block should emit error state. We're going to mark it with square brackets, so error. meaning that this is a state, when the input is invalid. So inside the range, we are not going to do anything special. We're just going to, again, call that when input converter's string to unsigned integer method is called, we should return not right, but left, because that's the failure side, and the failure will be precisely invalid input failure. And now we're finally going to do this testing a bit differently because we are using streams. Of course, inside act, we are going to again just call block.dispatch, and we want to dispatch the get trivia for concrete number event and pass in the T number string. What's interesting here is the assert part. Up until now, all of the methods we tested returned value themselves. For example, when we call input converter string to unsigned integer from the input converter test, if we take a look at that, when we call this method, it returns the value itself. It returns either a failure or an integer. But dispatching events does not return value. Dispatch returns actually void. The value of this dispatch call will be returned from a completely different place. That place is the block.state stream, which contains number trivia states. So asserting if the emitted values are correct is done a bit differently than we are used to. We are not going to say expect, but instead we're going to expect later. This will make it so that until all of the values which we are trying to test for are actually emitted, this test will be put on hold. Up to 30 seconds, of course, and then after those 30 seconds, the test will be deemed failing. So don't worry if you mess something up, the test will not just run forever. 30 seconds is the upper limit. And so we want to expect later that the block state stream, and now we somehow need to match what the stream emits. Thankfully, there are a lot of very useful matchers already implemented inside the Dart test framework for working with streams. So we can test emits, and now there are emits any of, emits error, emits in any order, but we want to check if the state will emit in a precise order. So emits in order is the matcher we want to use. And what should this state stream emit? Well, of course, the error state, right? So we're going to provide a list containing error state, right? And this error should hold a message containing the invalid input failure message, right? So that should be cool. But is this enough? Well, it's not. That's because blocks will always emit their first state to be the initial state. And the initial state in our case is empty. So we always need to specify empty as the first state which should be emitted. That's just something that we have to do. And let's actually make this code a bit nicer by extracting this list into its own variable, which we are going to call expected, so that it doesn't clutter up our code here, and pass in expected list to emits in order. And once we run this test, of course, it's going to fail because we have not yet implemented it. And actually here you can see that it does not fail immediately. It instead runs and tries to run for 30 seconds because it's expecting these values to be emitted later. But if those 30 seconds pass, the test will fail. And it did. However, let's just notice one more thing before moving on to the implementation of this functionality. We are dispatching the event, and only after that we are registering the matcher here that we are expecting that later on Bloc will emit these events in the given order. So is this a safe thing to do? Is it safe to dispatch an event before registering the expectation? it could possibly happen that the block will execute its logic faster than we can expect this later. I mean, it's never happened to me, but just to be on the safe side, we are rather going to move the assert part of the test above the act part, because we are going to register expect later before calling dispatch, and this way we can be absolutely 100% sure that we are never going to arrive in a situation where the logic inside the block executed before we had a chance to register this expectation. So instead of assert, we are going to call it assert later. So basically nothing changed, but we just made this more bulletproof. Now let's move on to the implementation. This string to unsigned integer returns an either type. So we're going to store it inside input either. And now we are finally going to utilize the true power of this either type, because we are forced to deal with both the success case and failure case. With regular exceptions, you can just ignore the exception. You do not need to wrap your code in try-catch blocks everywhere. You can safely ignore them, or safely, so to say, and then you're going to get caught red-handed that you are not putting try-catch blocks everywhere, because your app is going to crash at some point. With either, we have to handle both cases, and that's going to happen with the fold method, which accepts two higher order functions. The first one will be run whenever the left side is present inside the either, so whenever we have a failure over there, and then the right side will run, of course, when the call to string to unsigned integer has been successful. So if it's left, we're going to create a function here which will accept failure, and from it we're going to want to yield, which means emit a state, and the state we want to emit or yield to the stream is error. So error, and pass in the message. And we can already see that we have some problems here, because not even the IntelliSense wants to cooperate with us now. But anyway, we're going to finish this code. We want to emit the invalid input failure message, but something is not correct here. So what is that? Well, we are inside a higher order function, which is nested within another function, which is the async generator. But this async generator does not apply to nested functions, so we need to provide this async asterisk keyword even to this function. All right? We are nesting async generators within each other, and we need to provide this keyword for every single function which yields something. Now let's just handle the if right case, because we currently do not care about that, since we are only testing for the failure case here. It should emit error. We do not care about the successful part yet. That's gonna come in the next part. But we still have to handle even the right side of either, because that's the power of either. We have to handle every single case. So this will accept an integer, and we're just simply going to, for now, of course, throw an unimplemented exception or error, unimplemented error. And that's cool for now. We're not gonna get any problems from that, because this success case will not even run with the tests we currently have set up. But now we are only yielding this error state from within the higher order function. This means that the fold function returns a stream, and we want this stream from this fold function to be also returned from a map event to state itself. And we can do that by doing yield an asterisk, which means yield each. So every time we yield something from this higher order function, it's also going to get yielded from this containing function map event to state, which in turn will emit it as a state to the state stream of our block, and we can then check inside the test if the order of the emitted states has been correct. All right, so that's quite confusing to some of you probably if you've never tested with Bloc or even worked with Bloc. I really recommend you to check out my more basic tutorials on Bloc if you haven't already, and definitely go through the written tutorial, to which you can get from the link in the video description, because over there you can really go over this information at your own pace, and information in a written form like that is probably better and easier to comprehend than from a video. But anyway, let's now run the tests, and we should have successfully implemented this test. And surely we did. In this part, we've started implementing the number trivia block, doing test-driven development with streams, and you've also seen the reason why either is awesome, because it forces you to handle both cases, both the failure and the success. So there was definitely a lot to learn in this part, and there will be even more to learn in the next part, because we are going to finish the block, making it handle both the concrete and random events fully. If you don't want to miss that part and also more tutorials like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder I am determined to provide you with the best app development tutorials and resources out there. If this video helped you with understanding testing with streams and all of that good stuff, give this video a like and also share it with other developers who will surely benefit from it too. Leave a comment if you have anything to say, any suggestions or questions, and see you in the next video.